Hey class, it's Professor Nick Stensky at UNC Charlotte, and this is another Grasshopper demo for Lecture 3. I'm going to be talking about a specific kind of paneling system using morphed geometry. So we're going to take some geometry and apply it to a surface by distorting it. Okay. What I've got here is a file. I've got a surface, and in this case, it's an enclosed surface with open ends, so it's kind of like a tower. And I've got some geometry that I made in Rhino. And this geometry could be parametric. It could be something that you make parametrically in Grasshopper, or it could be something that you model in Rhino. Doesn't necessarily have to be square, but this is what I have. And I have one type that's just a box, and I have one type that's kind of a cube with a hole cut in it. And what I'm going to do is I'm going to wrap these around this geometry, and they're going to be distorted to fit that geometry. So first thing I'm going to do is I'm going to reference my surface. So take a surface container, reference, and I'm going to hide this. And I've talked about this before, but if you notice that the geometry is kind of faceted, it's not really smooth, that's okay. That's just the approximation in the computer. If you bake it, it's actually going to be just fine. So I'm going to take that, and I'm going to use our pattern that we've been looking at to divide the domain of the surface. And then I'm going to do an ISO trim. So take the domain, plug it in for D, take the original surface, plug it in, and I'm going to get a subdivided surface. And you can see that that one's actually smooth. I'm going to go ahead and hide my other surface, and then make some sliders for UV. So now you can see that when I adjust these parameters, it's going to change the panelization. Okay. So what I'm going to do is I'm going to take basically going to morph some geometry, and what that's going to be is it's going to be a box morph, and a box morph takes the geometry, it takes a reference box for that geometry, and a target box, which is where that geometry is going to go. Okay, and the way that this is going to work is I'm going to reference my geometry. Just make 2 copies for right now. So I'm going to reference this box, and then I'm going to reference this box. Okay. And then let's go ahead and hide these. So now I've got 1 reference, 2 reference. Okay. And the first one I'm gonna distribute is just this one, just to see, and then I'm gonna do something with a call pattern to distribute both of them. So geometry goes in. I need a reference box. So I need to figure out how big the area is within a box-like area. So I'm gonna do a bounding box. And a bounding box is just a representation of the area that something occupies as a box. It's actually pretty dumb. So if I hide this, it's just a box because I made a box. So my bounding box goes in for the morph, and then I need targets to apply this to. And one tool to do that is called a surface box. And what this does is it's going to distribute boxes all over the any surface. Basically, it takes a surface and creates a box. So take the base surface and the domain, which is actually the one thing we got here, and then you can see it's actually creating this kind of wireframe boxes. What I'm going to do though is I'm actually going to take the height and well, add a slider for height. That's fine. And I'm actually going to extrude these in a negative direction because negative is actually out, and that's what I want. I'll show you in a second. So see, it goes out. Let's kind of tidy this up here. Got this. Got my geometry. Okay, so I got a bunch of boxes. And if I plug my morph into those, I plug my surface box into those morphs, I'm going to get, and this might take a while to process on your computer because it's actually going to take the geometry of one box and distort it to fit the other box. So we've got this geometry that's in this container, and it's going to be morphed to fit this other container. Yeah, and so yeah, after a little bit here we go. So our thing has been, pinched and pulled and morphed and distorted to create this interesting kind of facade piece. And again, this is going to slow my computer down, but this is parametric. So if I change the surface box, which is the target geometry, I can change the thickness of it, and it's going to be pretty slow here, but we'll see if it likes me. Yeah, it's going to happen very slowly. You may want to turn off Morph. You may want to disable it as you work if you want to play with the parameters, because it actually gets very slow, and it might even crash your computer. Okay, so now it's finally completed. You can see it's thinner than it was. So that's parametric. I can go back and change these parameters to change the density of it. So that's a really interesting technique for trying to panel. So something else you can do with it is have this other geometry that we referenced. That's it's kind of a dumb box here, but you could have another type of geometry, and then using a cull pattern, you could distribute two different kinds of geometry to your surface. So I'm gonna go ahead and disable the morph for now, and what I'm gonna do is basically just take the surface box, and I'm gonna send half of the surface boxes to this morph, and then half to another morph that I make. So I'm gonna put this geometry in for this, and put it in for this morph, and then I'm gonna do a dispatch. Remember, a dispatch is some kind of pattern that's gonna send the true ones to A and the false ones to B. So I'm taking the boxes as my list. I'm gonna send these target to A, and I'm saying it's A to the target in that morph, and B to the target in this morph. Okay, hopefully everything worked. Let's have a look. Yeah, so again, these are one kind of geometry, here, and these other ones are going to be the other kind of geometry, which are the kind of circles. So kind of a candy cane kind of thing. But now, why is that in bands? Because probably we have an even number. So if I would go through and change one of these sliders to something else, I'd probably get a slightly different pattern. I might get a nice checkerboard pattern, I hope. Let's wait it out here. No. Okay. Maybe this is the magical. Yeah. So if you get the patterning, if you get the number right, true false, true false, true false is going to create this kind of pattern that's more like a checkerboard. So you have an alternating pattern, and anytime you've got some logic, you've got true false. You can always do things like you can do some kind of Boolean test. So you can say like, if a value is greater than something, it's true, and if it's not, it's false. Or if the point on that surface is touching some object, then it's true, and if not, it's false. And with these tests, you can create different kinds of patterns on your facade. Okay, so we'll be talking more about that on Thursday, but this is the general method for creating a morph box piece of geometry. And of course, you could go in and bake that geometry, and that's going to be something that you can use in your models. So again, this was just a simple demonstration of the morph box technique. Let's have a look at this. Yeah, well, there's one piece of the geometry, but you can see it's pretty good, pretty fluid. So that's it for this one, and I'll see you guys in lab on Thursday.